Alright guys, so today we're deciding if something is linear or not, which we got the super basic definition of just a straight line the other day, and today we're going to get a little more specific about what constant rate actually means. So first we're going to just practice ordering pairs and writing down what they are. Why? Because this is important. You actually need to know how this is. So on the first problem it says negative 4, 4 is A. On the second problem, here's B. So we go over 1, 2, 3, 4, 5 in the x direction, and we go up 1, 2, 3, 4 in the y direction. Perfect. Then C is just over 3 in the x direction, up nothing in the y direction. D is over 1, 2, 3, 4, 5, 6, 7 in the negative x direction, and then we went 2 in the negative y direction. Then on E, we went down 1, 2, 3, 4, 5, 6. So we went over 0 in the x direction and down 6. Hopefully you could have gotten that on your own, but those were all lovely. All right. So we're going to do some quick review of solving for y because we'll need this later on in this unit, but we're practicing it here to get it back into our brains. All right, so my first goal would be to get y all alone. Well, there's already one y, so we just need to subtract 4x from both sides because 4x has no y's in it. And then we have 1y equals negative 4x plus 6. Yes, you want the x first. Just trust me. All right, and on the one over here, we subtract 3x from both sides. So then we'd have negative 2y equals negative 3x plus 7. And we want the negative 2 to go away. Well, the way we do that is we divide by the negative 2. And when we divide by negative 2, we divide literally everything else by negative 2. And we get y equals, a negative divided by negative is a positive. So we have 3 halves x, and then we have a positive divided by a negative is a negative. And then I'm just going to leave it as 7 halves because it doesn't reduce nicely. So there's our one equation. Here's our other equation. Aren't they beautiful? All right, moving on. Remember that an ordered pair is always written as x, comma, y. And in each quadrant, they have difference. So in quadrant 1, both are positive. In quadrant 3, both are negative. And then these are where they get more specific. So in quadrant 2, x is negative, y is positive. And in quadrant 4, x is positive, y is negative. This is called the point of origin. You know it as the point 0, 0. All right. So what are some solutions for the equation of x plus y equals 6? I've written down some for you. So we've got 2 plus 4 equals 6. We've got 6 plus 0 is 6. 8 plus negative 2 is 6. 1.1 plus 4.9 is 6. We could also do 1 plus 5 equals 6. Or we could do negative 1 plus 7 equals 6. Or we could do 1.2 plus 4.8 equals 6. Do you start to see that there are a lot of combinations that equal all of these? Okay, so we're going to take these numbers, mostly the whole numbers, and we're going to graph them. And we're going to see if this is linear. So we knew that 0 plus 6 is 6. 1, 2, 3, 4, 5, 6. So this point here. And we also know that 6 plus 0 is 6. 1, 2, 3, 4, 5, 6. This point right here. We also know that 5 plus 1 is 6. And 4 plus 2 is 6. And 3 plus 3 is 6. And 2 plus 4 is 6. And 1 plus 5 is 6. And I bet we could keep going. We've got the negative 1s. And the 7s. The negative 2s and the 8s. Does this look like a straight line to you? It sure does to me. Well, that would be most convenient if it was a straight line, because it is in fact linear. So that one's linear. So the way we can tell, to determine linearity, we must have at least 3 points. So we could have a full table of points, but we need at least 3 to determine that they have the same rate of change. In other words, the change in y is the same as the change in x. And we're going to find that by creating a bunch of tables. So right here's our points. So we're going to go over 2, up 4, over 5, 3, 4, 5, up 1, 2, 3. And we're going to go over 8, up 2, and then we would go over 11, up 1. This looks pretty linear, so let's check it out. We're we're going to make a table. So here's my x's, here's my y's. We've got the point 2, 4, 5, 3, 8, 2, and 11, 1. So from 2 to 5, I need to add 3. From 5 to 8, I still add 3. And 8 to 11, I still add 3. Well, that's convenient that my x's stay the same because that's what's going to be important over here. So 4 to 3, I subtract 1. 3 to 2, I subtract 1. And 2 to 1, I subtract 1. So the way I see this, if this works, is I would do negative 1 over 3. And I want to know, does that equal negative 1 over 3? And does that equal negative 1 over 3? And in each case, negative 1/3 equals negative 1/3. So this is my rate of change. Some of you already know its more fancy name. We'll be talking about that later. Alright, so looking at this one, we're going to see what if it has a rate of change and if it's linear. Okay, so the rate of change we find by putting it in the table, and then we decide if it's linear if the rate of change is always the same. So here we're going to go ahead and graph it. So we've got negative 1 and 1/3, so that's about like there-ish. Then we've got 0 and up 1. Then we've got up over 1, up 1, 2, 3. And then we're over 2, up 9. Well, that doesn't look super linear, but let's see what's happening. So I've got my x values and my y values. Negative 1 and 1/3. 0 and 1. 1 and 3. 2 and 9. So between negative 1 and 0, that's going up 1. Between 0 and 1, that's going up 1. Between 1 and 2, that's going up 1. It's very nice that my x's are staying the same. So negative 1/3 to 1, that's going up 2/3. 1 to 3, that's going up 2. And then 3 to 9, that went up 6. It's not looking linear here, but let's check it out. So then I'm wondering, does 2/3 over 1 equal 2 over 1? This is a question, remember. Equal, question, 6 over 1. And in each case, they don't. So is it linear? No. Alright, so that's what you're doing for the rest of today, is you're just graphing it, setting up a table, seeing if that relationship between the change in y and the change in x is the same. So you're going to do that for these ones, and these ones, and these ones. And then you're going to write what makes a function linear. I told you at the beginning. You've gone over it a lot. Hopefully you know. And then write your summary, and you are done for today.